Bismillahirrahmanirrahim is start with the name of Allah, who is the most gracious and most merciful. My name is Zishan Ali Jagirani, roll number 2K18 LCS 45, improver. Today my topic is Introduction to Data Structures. Definition: Data structure is representation of a logical relationship uh, existing between the individual elements of data. In other words, a data structure is a way of organizing all data items. Data coincides only the elements stored, also their relationship to each other. Introduction: Data structure affects the design of both structural and functional speech aspects of program and program algorithm. Data structure, that algorithm is a step by step procedure to store a particular function. The MEMS algorithm is a set of instructions written to carry out a certain task, and the data structure is the way of organizing the data with their logical relationship retained. To develop a program of an algorithm, we should select an appropriate data structure for that algorithm. Therefore, the algorithm and his associated data structures from a program. Classification of data structure. Data structure is normally divided into two broad categories: primitive data structure, non-primitive data structure. Classification: data structure primitive DS, non-primitive DS, and there are types of primitive DS, and these are integer, float, character, pointer. Non-primitive DS, and it is also a parts linear list and non-linear list. Primitive data structure. They are the basic structures and directly appeared operated upon by the machine instructions. In general, they are the difficult representation on different computers. Integer, floating number, characters, constants, string, constant, pointers fall in this category. Non-primitive data structure. There are the more sophisticated data structure. They are divided from the primitive data structure. They are non-primitive structures emphasize on the structuring of group of homogeneous same type or heterogeneous if different type data items. Non-primitive data structure lists, sticks, the tree, graph are example of non-primitive structures. The design of an efficient data structure must take operations to be performed on the data structure. The most commonly used operations on data structure are broadly categorized into following types: create, selection, uploading, searching, sorting, merging, and destroy or delete. Different behaviors different between them. Primitive data structure is generally a basic structure that is usually built in the language, such as integer or float. A non-primitive data structure is built out of primitive data structure linked together in meaningful ways, such as array or a linked list, binary search tree, AVL tree, graph, etc. Description of various data structures. Arrays. An array is defined as a set of numbers of heterogeneous elements or same data items. It means an array can certain one type of data only, either all integer, all float, point, number, or all characters. Arrays. Simply de- declaration of an array is follows. And art 10, where and specifies the data type or type of elements array stores. N is the name of an array, the number specified inside the square brackets, and the number of elements an array can store. This is also called size or length of array. Following are the sum of the concepts to be remembered about the array. The individual element of an array can be assessed by specifying name of the array followed by the index or subscript inside square brackets. The first element of the array has a index 0. It means the first element and last element will be specified as array 0 or array 9 respectively. Arrays. The elements of array will be always be stored in the consequent continuous memory locations. The number of elements that can be stored in array, that is the size of array or its length, is given by the following equations: upper bound minus lower bound plus 1. For the above array, it would be 9 minus 0 plus 1 is equal to 10, where 0 is the lower bound of array and 9 is the upper bound of array. Array can always be read or written. Array can always be read or written through a loop of. If we read one-dimensional array, it requires writing the array. For example, reading an array for these are examples. Array. If we are reading or writing two different dimensional array, it would require two loops. And similarly, the array of n dimension would require n loops. Some common operations performed on array are creation of an array, traversing an array, insertion of a new element, deletion of an acquired element, modification of an element, merging of a list. A list, linear linked list, can be defined as a collection of variable number of data items. Lists are the most commonly used non-primitive data structure. An element of list must contain at least two fields, one for storing data or information and other for storing address of next element. As you know, for storing address, we have a special data structure of list B. Address must be pointer type. Technically, each such element is referred to as a node. Therefore, therefore, a list can be defined as a collection of models as shown below. List, type of list, linked list, single linked list, and dividedly linked list, single circular linked list, and doubly circular linked list. Stack. A stack is also an ordered collection of elements like arrays, but it is a special feature. Then deletion and insertion of elements can be done only from the called the top of stack top. Date to this property is also called as bait in the first type of data structural level. It could be through just like a stick of plates plated on the plate party. Uh, Guest always takes off a fresh plate from the top, and the new plates are placed onto the stack of at the top. It is a non-primitive data structure. When the element is inserted into a stack or removed from the stack, it will remain fixed where the top of the stack damage changes. Insertion of element into a stack is called a push, and the deletion of element and stack called a pop. The below show the feature of the below and the operation take place on a stack. Push top stack. The stack can be implemented in the two ways: using array static implementation, using pointer dynamic implementation. Queen. Queen is the first out of type of a data structure is 5-4. It is a coin new elements are added to the coin from the one and called the rear and the element are always removed from the other and front end. The people in standing is in a railway ex- and a railway reservation of row are an example of coin. Each new person comes and stands at the end of a row, and person getting the reservation confirmed get out of the row from the front. The below show figure operations take place on a stack. The queen is also implemented in two ways using array static using point and dynamic implementation. Trees. A tree can be defined as a finite set of data items, nodes. Tree is non-linear type of data structure in which data items are arranged or stored in a sorted sequence. They represent the by hierarchical relationship between various elements. In trees, there is a special data item at the top of hierarchy called the root of a tree. The remaining data items are uh, positional and into the number of numerically uh, mutually mutually exclusive subs, each of the which itself tree, which is called save of tree. The tree The tree always grows in the length towards the bottom in data structures, unlike the number trees which grows upward. Their trees structure organizes the data into the branches related to the information. Graph is the multi mathematical non-linear data structure capable of representing many kind of physical structure. In fine application in geography, chemistry, and engineering structures. And each contains a pair of wave varieties, and many have a weight such as length, cost, and another meaning measurement instrument for according to the graph. Varieties on the graphic are shown point circles and edges are drawn are arcs or line segments. Example of graph. Types of graph: directed graph, undirected graph, simple graph, weighted graph, connected graph, non-connected graph. Thank you so much.